Hello, welcome back to Hocus Pocus. Today we'll be expanding a little bit on the probability that we already talked about. Now, the core of probability is just weighing the number of outcomes that are desired against the number of outcomes possible. With this in mind, one of the most important tools at our disposal is permutations. Permutations are ordered lists of objects from a given population, and we'll first be examining them with repetitions. When people are talking about repetitions and probability, what they mean is whether or not you are removing an object from circulation. Think about it like rolling a dice versus drawing cards for a hand. You always have the same number of options per roll, but if you don't return a card, you can't draw it again. When we are talking about permutations with repetition, the formula is simply the number of outcomes is equal to the number of objects to the power of the number of events. So, for example, if you draw 5 cards, returning each card and shuffling the deck after you've drawn it, you have 52 times 52 times 52 times 52 times 52 outcomes possible, or 52 to the power of 5. Alright, let's look at a colorful example. You are a magical hot pot machine. You can, out of thin air, create 6 different ingredients for a tasty meal. However, you can only add up to 5 per meal. As you are a hot pot, you care about the order of ingredients. How many meals can you make, assuming you allow the chef to repeat his choices for ingredients? If you'd like, feel free to pause right here and to give it a shot, otherwise we will cover it shortly. Alrighty, since you can pick from 6 ingredients 5 times, the answer is 6 to the power of 5, or 7,776 meals. If you're an opinionated little hot pot and have 6 favorite meals, your odds of getting an ideal meal are 1 in 1296. But let's get back to the question of repetition. In our next case, we're going without repetition, so our previous outcome will get removed from the possibilities. This means that our equation is n factorial divided by the difference of n and r factorial, where, again, n is the number of objects and r is the number of events. In this case, n must also be greater than r. Example time. Let's say you were drawing 5-card hands from a full deck. There are 52 permute 5 possible hands for you to draw if you're paying attention to the order in which you receive the cards. As that is 52 factorial divided by 47 factorial, there are a lot of possible outcomes. 311,875,200 to be exact. Okay, problem time. This time, you are a slightly less magic hot pot machine. As before, you can add any of 6 ingredients 5 times, but now you are unable to add more than one of the same ingredient. How many meals is it possible to make now? Being a hot pot machine, you still care about order. If you'd like, take some time to think it through. The answer is 720 meals. Since you're still a hot pot in this case, if you wanted to make a particular meal, the odds of it happening would be 1 in 720. Alright, that's about it for permutations. Next time we'll go over combinations. Now, a lot was said here today. If you have any questions about anything or you would like to see something else covered, feel free to let me know. But, yeah, that should be it. This has been Hocus Focus. I hope you all have a wonderful day.